Hey everyone, today we'll be doing we'll be learning the difference quotient, and what the difference quotient is basically the basics of calculus. So we're gonna be learning about um, uh, like how the derivative came to be, right? So there's a formula for the difference quotient, and that is limit as h approaches 0, f of x plus h minus f of x all over h. Alright? So this is the basic formula for the difference quotient. And to solve this, so let's say I have f of x, okay? F of x is equal to x squared. Okay? So in order to find the first term, which is f of x plus h, I would have to put in x, I would have to replace x plus h into x. So f of x plus h would be x plus h squared. So what I did here was I just put x plus h all into x. So it's x plus h squared. So that's how you would uh, uh, find that first term. And then we already know what f of x is. So what we're going to do now is we're going to try and solve this problem. Okay? Limit, actually, let's get a bit above here. So we know that this is what we're trying to solve, and this is the formula. So we know that limit as h approaches 0, f of x plus h is what? It's x plus h squared, right? Minus f of x, which is x squared, all over h. So the first thing we have to do is we have to expand x plus h squared. X plus h squared is nothing but x plus h multiplied by x plus h. Basically 2x plus h multiplied by x plus h. And if we use FOIL, we do this, multiply this, and then multiply that, right? So it's x squared plus xh plus xh, which is 2xh, plus h squared. So this becomes limit as h approaches 0, x squared plus 2xh plus x squared minus x squared over h. So to this point, all we have done is literally replace the terms with newer terms, right? Like for example, over here, f of x, we replaced x squared. This term with x squared, replaced x plus h, f of x plus h, with x plus h whole square over here, right? And we replaced this whole x squared plus 2xh plus h squared, this whole expanded form with that, right? We've replaced that with this, right? So we've got this. Now from here, it should be pretty simple because now it's just going to be basic algebra. So it's going to be x squared minus x squared. So you can just delete that. So we have limit as h approaches 0. Whoops, what just happened? H approaches 0. X squared, we know it's gone. So we can just put the rest of the term here, x squared all over h. Okay, so we have 2xh over h squared. Now, from here, this should be pretty simple. This is just basic algebra, right? So we can just delete h and h everywhere. So it's just going to be limit as h approaches 0 of 2x plus h. Okay? H approaches 0, so we can just put the 0 in there, so it will be 2x plus 0, and then we would get 0. I mean 2x, my bad. And let's try to use the power rule to confirm that our answer here is correct. So f of x equals x squared, right? F prime of x should equal, if 2 is a power, we have to subtract the exponent by 1. Move that here. So it'll be 2x to the power of 1. And that's what we have over here, 2x to the power of 1. So that's how you would do the difference quotient in order to find the derivative, or the fundamentals of the derivatives in calculus. In the next video, we will be approaching the same thing, but we will be doing an MIT problem for difference quotient. And yeah, I'll see you then, and I hope you guys can review this stuff so that we can get onto that. I would say it's a bit complicated for a beginner, so make sure to do a lot of practice with this, and it should help in our next video. And make sure to like, subscribe, and comment, and I'll see you guys in the next video. See ya.